negative x squared plus minus 2x plus 3. Well, doing a table of values for it, go from negative 5 to 5. Something that's really interesting from this form too is that if you sub in x equal to 0 here, the y-intercept is that. Okay, so when x equals 0, we get the y-intercept. Subbing in x equal to 0, we just have the constant term, the c. So c ends up being the y-intercept in this form. Okay, so the table of values looks like this. Well, when y equals 0, we have the x-intercepts, negative 3 and 1. The symmetry seems to happen around the point negative 1, 4, and it seems to be the highest value, 4. All the other y values are lower. Okay, and we have the x-intercept at 1 and negative 3, the y-intercept at 0. So let's plot this. When we plot this, we get this nice graph here. So I just plotted the highest point, the vertex, okay, and then I plotted the x-intercepts, and the y-intercept is at 0, negative 3. And you could plot other points as well if you wanted. And notice as you go over 1, it's down 1 now. Okay, so this negative here seems to have made this parabola open down. So the negative a determines whether it opens up or down. Okay. If we factor it, well, factoring that one, we get it to look like this. So we could have a negative out in front, factor that negative out in front of the whole thing, then do the product sum, and you get this factored. Now, negative 3 and 1, the zeros, so the values of x that make y 0, they're called the zeros, okay, are negative 3 and 1. Well, those happen to be the x-intercepts. Okay, so we have the x-intercepts, or the zeros, of a quadratic relation. Okay, completing the square of this, well, we get this format here, and so there's completing the square. So we get a negative out in front. That negative keeps staying out in front, right? Tells us that it opens down. X plus 1 squared plus 4. The vertex was at negative 1 and 4. Okay, so we look at the graph here. The vertex was at negative 1 and 4. Okay, so we have the vertex comes from the completing the square, called vertex form, and the factored form gets us the x-intercepts, or the zeros, of the quadratic relation. Okay. Take a look at one more here. This one, y equals x squared minus 4. Now this is a difference of squares, and when you do the table of values, it looks like this. Alright, so the a is still 1, and each time you go past the lowest point here in the table, you're going down, or you're going up 1. Then if you go past it by 2, you're going up 4. So we'll go past 1, 1 squared is 1. Go past by 2, 2 squared is 4. Pass by 3, 3 squared is 9. So you go negative 4 plus 9 is 5. Negative 4 plus 9 is 5. Okay, and you keep thinking like that when the a value is 1. If the a value is 2, that would all be doubled. Okay, so here is the graph that you get, and you notice the symmetry in the table. The factored form is here. It's a difference of squares, easy to factor. So the x-intercepts are plus and minus 2. Okay. And completing the square, we've got it looking like this. It's the same thing. It's just x squared minus 4. Okay, so it's already in the form of completing the square. So you can take the vertex out of it by 0, negative 4. Okay. And another one, take a look at here, is x squared plus 2x plus 1. This is a perfect square, okay, and doing the table of values, we get the symmetry is around -1, 0. So moved over there. Plot the graph. We've got this. Factoring a perfect square, well, we know that half of 2 is 1. 1 squared is 1. So we know that this is a perfect square. And we've got one x-intercept. So in a perfect square, we get one x-intercept, because there's only one value of x that makes y 0. Okay? The y-intercept comes from here. When x is 0, y is 1, so you can plot that. And it's as simple as this when you graph it. Okay? Completing the square, well, factored form is the same as vertex form for this one when you complete the square. And you get the vertex is -1, 0. Okay, so -1, and there's this plus 0 that you don't have to have out there. Okay, and two more simple looks here are, what about y equals -x squared? Well, as I mentioned before, y equals -x squared looks like this, opens down. Y equals 2x squared. What about, look at that. Well, the table of values here that we had for y equals x squared, all these would then be doubled. So you go over 1 and up 2, over 1 and up 8, over 2 and up 8, over 3 and up 18, and so on. Okay, so here is how y equals x squared would look in red. And if that's y equals x squared, then y equals 2x squared would move up faster. It's been vertically stretched by 2. Okay? And y equals 1/2 x squared would look wider, or it's kind of squished down vertically. So it's been vertically stretched by 1/2, or compressed. Okay? So with these two, then, we have a vertical stretch of -1 for this one, which means it flips it upside down. And we have a vertical stretch of 2 for the one that goes up fast here, and a vertical stretch of 1/2 for the one that goes up slower. Okay. So let's look at translations and transformations in general, which involves translations and stretch factors. Okay, so thinking of this quadratic from y equals x squared, what has happened to it? Well, if you go to graph it, the vertex is now at 2 and 3. Okay, so it's moved over to the right 2 and up 3. Okay, so when we take a look at this graph, the vertex is at 2, 3, and it opens down because of the negative. And because it's been stretched by a factor of 2, if you go over from 2, if you go over 1, you're going to go down 2. So that is, those are two key points there. So the normal y equals x squared, if you go over 1 from the vertex, you go up 1. If it's -x squared, you go down 1. Since it's been vertically stretched by 2 here, you're going to go over 1 and down 2. Because it's negative, you go down. So we have some notations here. So from y equals x squared, this parabola has been vertically translated, means vertically shifted 3, so moved up 3, and horizontally translated 2, so moved up 3, horizontally translated 2. And then the VSF, the vertical stretch factor, is -2. The negative means down, so it opens down, and then the 2 means it's been stretched vertically by a factor of 2. On this, we got the y-intercept is -5. Okay, how do you get -5? Well, you can plug in 0 in for x. Now, something else you can determine from this are the x-intercepts. Okay, so we've got the transformations right here, and then we've got a y-intercept, which is -5. How could we get the x-intercepts? Well, we could let y equal 0. That's how you get the x-intercepts. So when y equals 0, you could then expand this all out. Okay, so just as I've done here, determine the x-intercept. So expand that all out, okay, until you get it into standard form. And if it's not factorable, which it's not, there's no two numbers that multiply to give you 10 and add to 8, okay? So there's no two integers, sorry. So if you set this equal to 0, then you can solve for the x-intercepts. Well, the only way to solve that, we know there are x-intercepts because of the way it opens, is to use the quadratic formula at this point. Okay, so you plug in negative b plus or minus b squared, which is 8, minus 4ac all over 2a. Simplify that and you get approximately, so approximately 3.22 and 0.78. Looking over here, that makes sense. There's 1, so back a little bit is about 0.78. And here is 3, so 3.22 would make sense for the next, for where it crosses the x-axis. Okay, so that's a way of getting the x-intercepts. You could also have got it by leaving it in vertex form like this. Okay, so leaving that form, setting that equal to 0. So I'll show you that right now. So setting that equal to 0, you get 0 equals negative 2 x minus 2 squared plus 3. Okay, so how can you then solve this? Well, we had a method for solving quadratic equations by completing the square. You've already completed the square here, or it's already been done for you. So now you can bring the 3 over. So you get negative 3 equals negative 2 x minus 2 squared. Divide by negative 2, so you get 3 halves equals x minus 2 squared. Okay, now you can, to get rid of that squared, you'd do, so I can just change sides here, so x minus 2 equals plus or minus the square root of 3 over 2, and now you can bring the 2 over, so x equals 2 plus or minus the square root of 3 over 2. Now looking at this, the graph here, so 2 is that centering point here, so it's right where the vertex is, the h value of the vertex, or the x coordinate of the vertex. Okay, so now you add root 3 over 2, which is a little bit more than 1, to here, and you subtract root 3 over 2, and you get a value right there. Okay, so that also equals, where the numbers 3.22 and 0.78 approximately. Okay, so those are that's another way of getting the x-intercepts from vertex form. Okay, so looking at this one here, well, we had this before, so x squared plus 2x plus 1. When we take a look at the factored form, okay, and vertex form, completing the square, it's been moved to the left 1. So it's a horizontal translation to the left 1, and that's it. Okay, so in this one here, if you look at x squared plus 1, this is a vertical translation, okay, up 1. But if you have it in brackets inside, then it has to be a horizontal translation. Okay, so x plus 1 squared is a translation to the left 1. X minus 1 squared is a translation to the right 1.